Today we're going to look at Chapter 2, Lesson 3, the remainder and factor theorem. Now, Chapter 2, Lesson 3 focuses on factoring polynomial functions as well as evaluating polynomial functions. So example 1 says factor each polynomial completely using the given factor and long division. So in letter A, we have the polynomial x cubed plus 7x squared plus 4x minus 12. Now, if I cover everything up, okay, and I asked to factor, okay, we would factor by finding a GCF of the first two terms and a GCF of the last two terms. It's called factor by grouping. Okay, if I factor out an x squared, I'm going to get x plus 7 for the first two terms. And if I factor out a 4 in the last two terms, I'm going to get x minus 3. This presents us a problem because in order to factor by grouping, the quantity in parentheses where I had x plus 7 and x minus 3 would have to be the same. And in this case, it's not. So I cannot factor by grouping. Now, because we were given that one of the factors is x plus 6, I can factor the polynomial using long division. So what I'm going to do is I'm going to divide this polynomial by the factor x plus 6. So I'm going to put x plus 6 outside of my division symbol and the polynomial inside, x cubed plus 7x squared plus 4x minus 12. Okay, when I divide a polynomial using long division, I focus on the first terms. Okay, so I have my x and I have x cubed. What I'm going to do is divide those. X cubed divided by x is x squared. Now I'm going to put the x squared up here at the top above x squared so that I can keep everything in order. Okay, so step number 1, okay, I divide x cubed by x, and I get x squared. Now what I'm going to do is I'm going to multiply both the x and the 6 by x squared. Again, multiply x and 6 by x squared. If I take x squared times x, I get x cubed. And I want that to match that first term. And if I take x squared times 6, I get a positive 6x squared. Now what I'm going to do is I'm going to subtract this quantity from the first two terms. Now I'm subtracting, so x cubed minus x cubed is 0, and we need that to be 0. 7x squared minus 6x squared is 1x squared, or just x squared. Then I'm going to bring down the next term, which is a positive 4x. Okay. So step number 3, what I just completed, was I subtracted. And then step number 4, I bring down the next term. So I brought down the 4x. Okay. Now I'm back to the process that I just completed. I'm going to look at first terms. I have my x, and now I have an x squared. So starting over, step number 1 again, I'm going to divide x squared by x. X squared divided by x is a positive x. So up here at the top, I'm going to put plus x. And I'm going to multiply this x by the first two terms, both x and 6. So multiply x and 6 by x. So x times x is x squared. X times a positive 6 is a positive 6x. And just as I did before, I'm going to subtract both terms from the x squared and the 4x. So step number 3, subtract. x squared minus x squared is 0. Again, we want that first term to be 0. 4x minus 6x is negative 2x. Okay. Then I'm going to bring down that last term, negative 12. So step number 4, and bring down negative 12. And then I'm going to repeat this process one last time. So I'm going to divide x into the negative 2x. So divide negative 2x by x. Negative 2x divided by x is negative 2. Then I'm going to multiply the negative 2 by both the x and the 6. So multiply x and 6 by negative 2. So negative 2 times x is negative 2x. Negative 2 times a positive 6 is negative 12. And last, I'm going to subtract the two sets of terms. Okay, so when I subtract, remember, I'm subtracting both terms. When you subtract with negatives, okay, we would actually add the opposite. So if I change this to a positive, then I need to change the negative 2x to a positive and the negative 12 to a positive. Subtraction is the same thing as adding the opposite. So negative 2x plus 2x is 0, and negative 12 plus 12 is 0. Because the remainder is 0, then I know that the factor x plus 6 divides evenly into the polynomial. Okay, so what I have remaining is the following factored form. I know that my polynomial is equal to the quantity x plus 6 times x squared plus x minus 2. Okay. So if I were to go through and distribute x plus 6 to my polynomial, I will get back to the original polynomial. Well, notice this is a quadratic, and I'm pretty comfortable factoring those. So I'm going to go ahead and break that down to a product of two binomials. I know that x times x is x squared. And I have negative 2, so I'm thinking of a pair of numbers that multiply to make negative 2 and add up to a 1. And that's a positive 2 and a negative 1. And I have now factored this polynomial completely using long division. In example number 4, we're going to go through the same process. We are going to factor the polynomial completely, but this time we're going to use synthetic division. Synthetic division is a shorthand method for long division as long as our factor is linear. So notice that we are dividing by x plus 2. X plus 2 is a linear factor because x is to the first power. If this factor were to be to the second power or third power, we could not use synthetic division and we'd always have to resort back to long division. Again, we can only use synthetic division when there is a linear factor. Now, when we use synthetic division, okay, the first thing I need to do is take my linear factor, set it equal to 0, and solve. So I'm going to set x plus 2 equal to 0, and if I solve this, I know x equals negative 2. Negative 2 is the number I'm going to use to complete the synthetic division. Now within synthetic division, we're only going to list the coefficients. That's the number in front of x. Okay? And it has to be in order from the highest power to the lowest power, and we have to include every power. So say I have x to the third power, and then it just goes straight to x and doesn't include an x to the second, I would have to replace the spot for x to the second power with a 0. Now this example, we have every term accounted for from the third power all the way down to the 0 power. Now x to the third power has a leading coefficient of 1. X to the second power has a leading coefficient of -2. X has a leading coefficient of -13. And x to the 0 power, which is our constant, has a coefficient of -10. Okay. So what I'm going to do is always drop down the very first term. My first term is a 1, I bring it straight down. Then I am going to multiply the -2 by any number I put below. So -2 times 1 is -2, and I'm going to place that below the next term. Now, looking down that column, I'm going to add those two numbers together. -2 plus -2 is -4. Then I multiply. -2 times -4 is a +8. As I work down the column, I add those numbers together. -13 plus 8 is -5. I multiply. -2 times -5 is a +10. And then I add. -10 plus 10 is 0. I usually put an X there for 0 because that last column represents my remainder. Since there is no remainder, I do know that x plus 2 divides evenly into the polynomial. Now, when you divide x cubed by x, the remaining polynomial will go down 1 degree. Okay, so this polynomial becomes 1x squared minus 4x minus 5. Now, if I'm going to factor this completely, I'm going to write this as the product of the linear factor and the quadratic factor. My linear factor I divided into the original polynomial was x plus 2. And the polynomial I got in return is x squared minus 4x minus 5. If it's possible, I need to factor the trinomial. So I'm going to keep the x plus 2. And I'm going to open up 2 sets of parentheses. I know that x times x makes x squared. I'm looking for 2 numbers that multiply to make -5 and add up to -4. Those numbers are -5 and a +1. And I have factored this polynomial completely using synthetic division.